Good morning.
Good morning. Thank you for waiting.
No problem. I was waiting for 10 minutes, so I was thinking,
I'm
what's going on?
so sorry.
No worries.
There was some internet issues and then nobody here had the password. So I was
Oh,
in a
okay.
panic.
Oh, okay.
Oh my goodness. Oh, how's everyone doing?
Good. How are you,
Good.
man?
I'm terrible.
Just take a deep
I'll be
breath.
okay in a minute. Right? Thank you. Oh my goodness. That was stressful.
I bet.
How's let me now that we're oh for goodness sake. Okay. We're gonna figure this out. So I wanted to give you some updates. We've had some of you know, oh gosh, it's already the there's been a lot of internet issues in the last week. And so some of you might be really confused about what's going on. So there's a couple updates that I'll also put on D2L because it looks like this internet will hopefully work. So today I'm posting your assignment and also the videos. I think maybe for the last two classes are not up. Is that true? Okay, so today I'll post the homework assignment and it will actually be two small assignments. One small assignment from last week and then one small assignment from this week. So it'll still be about 20 problems, maybe a little less, and let you kind of practice what we've been doing, which is graphing and inequalities and absolute value. And then on Sunday, your second exam will become available and it will be everything through everything 7, 8, and 9. And you'll have a week to do it, just like this last exam. And that way you will have a chance to get points back on problems that you missed by doing like some error analysis. The final exam is the last day of class. After class, because we'll still have that class session, but it's only 4 problems and they're more open-ended. So one question might be about transformations and having you kind of make a transformation. So you should have enough time to do the last exam because it's much shorter and is more open to letting you kind of lead the way that the problem goes, and I'll be looking for points to give you. And the only reason why you have less time on that last exam is because our grades are due the following Monday. So, and now that hopefully the internet will be working, the assignments that have been done in the meantime will be updated on D2L. And you should expect your exam ones to be graded by Saturday evening. So I know that was a lot of information. How are we doing?
Yeah, exactly.
Okay. So I guess the first thing would be your homework will be posted today as well as the videos, and you can start working on your homework. And I will be doing my end of updating things today and through Saturday. So, okay. After class on Tuesday, Kaku and Adnan stayed on and we talked a lot about, or a little bit, I guess, about inequalities. And Kaku asked an awesome question, which was like, can you tell me a little bit more about why this is? And I thought about it and I kind of came up with a way to explain that I think will help you a lot. So I'm gonna connect my iPad. And share. Okay, so let's start with a new one to begin with. So where we're going on Tuesday, we talked about compound inequalities. And compound inequalities, we were looking at the Venn diagram, which kind of looks like this, where you have one inequality here, which might be like x plus 2 is greater than 7. And then you will have another inequality over here, like maybe x over 4 minus 1 is less than or equal to 10. And the two ways that we are looking at these with compound inequalities is we're either looking at only this section, only the answers that would be for both. And that is often when we see the word and, because it has to satisfy this and that. And so the answers that we find for compound inequalities that are intersection, which is what that's called, intersection, they're the ones that if you graph both answers on a number line, both lines would be covered. And the way that these will look is either a word like x plus 2 is less than 7 and x over 4 minus 1 is less than 10. That's one way that they'll say it. Or it'll be in a compound form. And so in a compound form, I'm going to adjust that first one a little bit to make it x minus 5 is less than, and then you would have this middle part here, x over 4 minus 1 is less than or equal to 10. So those are the two ways that intersection problems about. And when we put our answers, there are two ways. It'll either be like with parentheses we were talking about before. I don't know what these answers are, but like maybe negative infinity to 5 inclusive or something like that. And the symbol, yes.
Ma'am, the second equation, x by 4 minus 1 is less than or equal to 10. Why we will not take the LCD for that to remove
so I don't know if this is the answer. That was just an example.
Okay.
But you would, yeah. Do you want to take a second? We can do it actually. So here, the symbol also is that. So let me take these two problems and we might get kind of an ugly answer. But we have x minus 5 was less than, oh, it was greater than. X over 4 minus 1, right? Was, oops, where am I? Less than or equal to 10. Okay. So this would be a compound. And if you see a problem like that, then it is inherently talking about the intersection, which is only that little spot in the middle. And so, like Adnan said, you could solve this a couple ways, but I think the easiest way to solve it is to clear fractions, which is to multiply everything by the least common denominator. And then Adnan, do you have an idea of what the least common is?
Ma'am, 4.
Yep, there's only one denominator, so that makes it easy. And so we're going to multiply this by 4, this by 4, and this by 4. And we're going to have to distribute. And so we're going to get 4 x minus 20 is greater. And then what happens here on the first one is we get 4x over 4, and then minus 4 is less than or equal to 40. And because we have this 4x over 4 right here, those 4's can cancel out because it's 4 divided by 4, which is 1. And that x, there's no addition or subtraction in that fraction. And so if there's no addition or subtraction in the fraction, you can divide out. And then we would have 4x minus 20 is greater than x minus 4 is less than or equal to 40. And then we need to isolate the x, but we actually have 2 x's here. And so I need my x to be in the middle because I need my answer to be x is more than this, but less than that in order to get a spot on my number one. So to do that, I'm gonna take this 4x, and I'm gonna subtract it from here, and I'm gonna move it into the middle. And now I have negative 20 is greater than, this is a 1, so it's going to be negative 3x minus 4 is less than or equal to 40. And now in the isolating step, everything that I do to the middle, I have to do to all 3 parts. We didn't have to do that here because I'm rearranging the problem so that the x's are together. But now I'm going to be isolating. And so I have to do inverse operation. Does anybody have questions about that? So I'm going to add 4. Okay. Add 4 to all 3 parts because I'm isolating that x. And I get negative 16 less than negative 3x, which is, or greater than negative 3x, which is less than or equal to 44. And then does anybody know what the next one would be?
Yes, ma'am, the sign's gonna change.
It is gonna change, very good. What are we gonna divide by?
Ma'am, 3.
What'd you say?
Ma'am, 3.
Are you sure?
Ma'am, I'm not
How
sure.
about negative 3?
Yeah, negative 3, yeah,
There
that's
you
what I
go.
mean.
I didn't mean to make you nervous.
I was thinking, what's going on? But every time I'm forgetting the
I
sign.
know, all those negatives. So now, we talked about this on Tuesday. We have these ugly fractions. And so a lot of times you can keep them as, like this one's gonna be 16 over 3. And he's right, we have to, because this is a negative, we have to flip all the signs. So this first one is a greater than, but we need to flip that to be less than. And that's like a special rule that you really have to remember when you're doing inequalities, where if you divide or multiply by a negative, you have to flip the sign. And so if I see in my very last step that my x has a negative coefficient, then I know that I'm gonna have to flip the sign. Sometimes it'll work out like in the problem where it's no longer negative, so always wait till the very last step. So I have 16 over 3 is now less than x, which is greater than or equal to, and then 44 over negative 3. A lot of times mathematicians will leave it like that. That's not my favorite. I like when you make it make more sense, where if you're looking at 16 divided by 3, that's 5 1/3. And then this one can be 44 divided by 3. You might need some help here. 44 divided by 3 is maybe 16. Hang on. 14. 14 and 2/3. That makes it make a little bit more sense to you on the number line. And so in here, we're going to say, because it's written in kind of a weird way, and so we're going to rearrange it. But when we rearrange it in this step, because this is our answer, this is our answer, but it's written in kind of a funky way. And so we're going to rearrange it. And now when we do that, we have to make sure that we don't accidentally flip any signs. So I need to make sure that my small side, which is right here, stays pointing to my negative 14 and 2/3. And this small side stays facing my 5 and 1/3. And so we're going to say negative 14 and 2/3 is my smallest absolute value, or my smallest number, I guess, in general. And so, let me keep scrolling. So I'm going to say my number line is going to go from negative 14 and 2/3, and then I'm going to keep it. See how the small end is at the negative 14? I'm going to write it this way, but I'm not flipping a sign. I'm just rewriting it. X. And then now I need the big side to be facing my X. And so I have my 5 and 1/3. And so you're going to say on a number line, it's negative 14, 2/3 is here, and 5 and 1/3 is here. Then we have, just this answer is X is greater than negative 14. And because it has this equal sign, we're going to do the square bracket. So X is greater than that. It's going to go all the way here on the number line. And then for this part, just look at this part here, which says that X is greater than 5 and 1/3. And so we have from 5 and 1/3 over here. And so the only part, oh, and it's the curve bracket. So the only part that has both lines, both green and blue, is from 5 and 1/3 to positive infinity. So my answer is going to be, based on this number line, that it is from 5 and 1/3 with a curve bracket to positive infinity, which also has a curve bracket, because that's just a special rule about negative infinity and positive infinity are always curve brackets. So that's a little review about compound inequalities that are intersections. And we picked a pretty hard problem to start with. So how is everybody doing?
Good, man.
Okay, good. So for absolute value, I'm gonna delete some of these things. We have two situations. And one of them is when you have whatever is inside the absolute value is less than A. And so we're going to go with like kind of an easy example. So I'm going to do the absolute value of X is less than 2. And so if the absolute value of X is less than 2, then that means that whatever is here is only going to be the answers that are less than 2. And so on a number line, that's from 0 to 2. It's this part right here. That's less than 2 because we have 1. 1 is less than 2, and maybe 1/2, yep, which is less than 2. But because it's absolute value, what other part of the number line should be shaded? What could also be 2 away? Yeah, -2. So because we don't know, because this could easily be -2, because the absolute value of -2 is 2. And so we would also cover on our number line from -2 to 2. Because both of these, as an absolute value, are 2. And so we have everything in this -2 and this +2 are going to be less than 2. And so because of that, when we solve these problems, we do have the part that we're given, which is whatever the absolute value is less than 2. But we have to add this piece that's -2. And that's what this rule is telling you up here. That if it's less than, then not only do you have your answer that you're given, you also have to add this part in the front, that x has to be greater than that same number, but as a negative. That way you get this part of the number line, which is less than 2, but you also get this part of the number line, which is less than 2. And so the example that we used, actually we can use a different one. Let's say that we had the absolute value of m/5 plus 3 is less than, let's say, 6. Okay, so we know that whatever is here has to be less than 6 on the number line.
Ma'am, your mic is off.
Thank God. It just stopped. Yeah, there you go, Lily. Oh my goodness. Okay.
You were thinking what happened?
This is not stress-free. Why? Oh, good. Okay. Oh my God. Okay. So hopefully this is making sense. And if our answer has to be less than 6, then that is this part of the number line, but it's also this part of the number line. And so we're going to add to this problem that it has to be greater than -6. I take this side of the problem, and the negative version of this is over there, so that my number line includes all of the positive values that already came with it, but then also the negative values. And then you would solve this the same way that we were just talking about with inequalities. And so we would say, this is a compound inequality. And so we're going to say -6 is less than, I'm going to drop my absolute value because I've already taken it into account. And then who knows what to do.
LCD, madam?
Yeah, you could do LCD. Yeah, you could multiply everything by 5. That would work. If you were thinking you could subtract by 3, that one would also, you could subtract by 3 on all of them and then multiply by 5. So I'm going to do that one for this time, but LCD is definitely an easy way to do it too. So I'm going to subtract 3, subtract 3, subtract 3. This is -9, not -3, less than m over 5, which is less than 3. And we're going to get multiply by 5. Do I have to flip the sign?
No.
No, because my
It's
coefficient is
positive.
technically, yeah, it's positive. It's technically 1/5, but we don't write it as 1/5. We just write it as divided by 5. So I'm going to erase this number line because it's going to become confusing now that we have a different solution. We just needed that to set up our problem. So we're going to get from -45 to 15. All of those answers from -45 to 15 will satisfy what's in the absolute value bars. And I'm going to show you an example. So you could write your answer as it is right there. M is greater than -45, but it's less than 15. Or you could write it as from -45 with a curve bracket to 15, also with a curve bracket. Does anybody know why I'm using curve brackets in this problem?
Because it's not a less than or equal sign. It's just less than sign and greater than sign.
Exactly, exactly. So there's no line underneath here. It's not less than or equal to. So if it's not less than or equal to, then you use the curvy bracket. Or if it's infinity. So let's pick a number that's between -45 and 15, but try to pick an easy number like 0 or 1 or 10 or -1 or 5 will be a good one. Somebody pick one of those numbers. Bueller.
5.
5, thank you. So 5 is a really great one to pick because it's m divided by 5. And so if I pick 5, that's going to become 1. And 5 is in our intersection here. So it's between -45 and 15, and 5 is in there. And so I'm gonna, all right, fine. Oh, there we go. Make this smaller, move that out of the way. And so what I'm gonna do now is substitute. I'm just checking my answer. So I'm gonna do -6, or actually I'm gonna do, well, that's fine. You could check a couple ways. So -6 is less than the absolute value of 5 over 5 plus 3, which is less than +6. So -6 is less than 5 divided by 5 is 1 plus 3. I dropped the absolute value bars here. You could drop them later, but I already saw that everything in here is positive. And so that's why they kind of went away. If you wanted to, you could keep them a few more minutes. And then you're going to get -6 is less than 4, which is less than 6. And you want to kind of check your answer by looking at one piece at a time. And so in the first part, I'm going to see, okay, is 4 greater than -6? Is that part true?
Yes.
Yes, very good. Is 4 less than 6? Yes.
Yes.
Good. So everything that we pick between negative 45 and positive 15, if we put them in, is going to come up with this true statement where the number in the middle is going to be less than negative 6, but more than negative 6, but less than 6. So when it's compound intersection, when it's less than up here, like we have this, less than gives you this middle section of the number line. So now we're going to look at if it's greater than. So if it's greater than, let me get a, here we go. So let's say that we have, we'll go back to an easy example. We have the absolute value of x is greater than, let's say 3. Okay, so when we see a number line here, in order to be greater than 3, instead of going inside on a number line, it has to be this outside part of the number line. For negative 3, it also has to be from the outside part. And so here's the difference where if it's greater than, you're going to end up having 2 different solutions, whereas if it's less than, it's going to be one in the middle. Does that kind of make sense? Hang on. You guys are going to write the goofiest evaluation for this class. Don't come back here. Stay over there. Okay, so we're going to take a few minutes and we're going to practice this. And then I'm going to give you an example because I think it's easier to do less than and then greater than separately. So give me 1 second and you're going to go to, oh, you can't see that. This is your participation points for today. You're going to go to www.ixl.com and I'm going to give you which one to do. They're going to give you 10 free practice problems. You're going to do 5. And then you're going to take a screenshot after 5. And I'll put a place on D2L for you to upload your screenshot. Everybody okay with that? Okay, give me 1 moment while I remind myself which one you are doing. So you're going to go to A1L3. So let me show you this. We're going to share something different. Okay. So you're going to go to actually I can put this in the chat. Go to that link and do 5 of the problems. And I'm going to assign you to some breakout rooms so that you can chat while you do them. But you're going to practice solving 5 of the problems. And then you're going to answer them in using these things right here. And then once you get to 5, you're going to do a screenshot. So we'll just do this first one together. So if I have the absolute value of 2W is greater than 2, then it's also going to be greater than negative 2. I'm going to solve them both as separate problems, which I'm not sure if you can see. So it should be that W has to be greater than less than 1. And then that's the value of 2W. Okay. And so then whatever you have as your solution, like let's say we had 1, then you could write it either, as they're saying here, as a compound, or if it's an or situation where the number line is going out instead of in, then you use this word or. And IXL might be a little particular about your spacing, but I think we should have W is less than 1, or W is greater than 2. Now, I didn't use these buttons, so it might get mad at me. Okay. Yeah, so I have the same answers. They're just going to give you something a little bit different. So we're going to practice this. And once you get to 5 on your questions answered, take a screenshot. Any questions?
Yes, where does this screenshot go on D2L?
Yes, that's a great question. I'm adding it right now. It'll go in assignment.
Okay.
So let me give you, do you want to choose your groups to people to chat with, or do you want to do random groups? You guys normally like to be in chosen groups. So give me 1 minute here. Yes, my love.
Can you send that MXL
Link
in the
again.
chat? Yeah, please, because I got.
Yeah, because if you get kicked out, you can't see the old chat.
Yeah.
Okay, hold on. It's not working. Of course, it's not working. All right, we'll do this. Join the room. I'll switch you around in just a minute because some of you are not with your friends. And I'll send the IXL. Chat again. One. Here we go. Lori, how are you doing?
I had to unmute you.
I said, how are you doing?
I'm lost. I just went to the IXL to see what it was. And
you're not sure how to do it?
No, I went to recommendations and skill plans and math.
Okay.
Just kind of.
Did you see the link?
Yes, I did do the link.
Okay. Okay. Give me just a couple minutes and then I can work with you. So no worries.
Okay.
I'm just gonna put the thing in D2L so that people have a place to put it.
Oh yeah, and I went to D2L2 to see where it should go. And then, so when we go to D2L, under assessments and assignments?
Uh-huh.
Okay.
But I'm making it now.
Oh, okay.
Okay, so it should be there. Make sure it's not hidden. Not hidden. Okay, great. I'm almost there. Okay, so I think this will help you. Let me share my iPad. Okay, so we have two different versions that we start out with. We either have the absolute value of x is less than a, or we have the absolute value of x is greater than A. And so, and the or equal to is basically the same. And so when you have these two situations, the first one is what we were talking about, how on a number line, it's going to be the part that's in the middle. So if you have A and you have negative A, then the answer is going to be in here in the middle. And the second part is going to be where now you have A and negative A, but you need to have the outside. So here.
Am I supposed to be am I supposed to be looking at something other than this D2L site that's up?
Oh yeah, can you see my iPad?
No, I just have the D2L site
Oh.
up. Okay. Oh, okay.
There you go. Sorry.
Mm-hmm.
Okay. So let me go over that again. So you
Okay.
have two setups. You have this first setup, which is whatever is an absolute value is less than A.
Okay.
And that's what this symbol is. And one way to remember is if you use your left hand to make the symbol L, left, less than,
Okay.
they all start with L. And that's the one you have. So less than A. If it's less than A, then if this is 0,
Oh.
I'll make it 0. If it's less than A, then it means it's going to be this middle section. Everything that's less than A here, and everything that's less than negative A here.
Okay.
And so when we have a less than problem, we rewrite it where we keep this part with A, but we add this part here with the negative A. That way we get both parts of the number line. The other version is where you have the absolute value of X is greater than A. And so if it's greater than A, then that's this number line down here, where you have everything that's greater than A, but also everything that's greater than negative A. And so this one up here, this is an and problem, an intersection problem, or it's just an and. Whereas this problem down here, this is an or problem, because you have either answers that are on this part of the number line or answers are on that part of the number line. And so when we have a greater than version, we do that twice, where we do X is less than whatever A is, but the negative value. That gives us this version. And then X is greater than A, which is the problem that we started with, which is here. So we'll do it with IXL. I think that'll make it easier. I'm going to go to IXL. This will count as your participation. Okay. So the problem on IXL, I don't want to switch you back and forth a bunch of times, but the problem on IXL says the absolute value of P, which is greater than negative 1. And so the kind of annoying thing about this problem is it started off with the absolute value on the negative on the outside. And so to get rid of that, I'm going to divide by negative 1. That's going to go away there. And so now I have the absolute value of P is this less than, because I divided by a negative 1, less than 1. Okay, so that's the problem we have to solve. Absolute value of P is less than 1. And so now when I go here, if it's less than, then it's this one up here. And so to be less than, I take whatever this value is, and I keep that part, but then I add this second part to be the negative version of that. And so I'll show you on this one. So on my so I have this first part, which is still true. So I have P where the absolute value of P is less than 1. But that will only give me the positive values. And so now I have to add in that it's also got to be greater than -1. Because on our A here, we have whatever this A is, we have the positive version of A, and we have the negative version of A. So in our case, our A is 1. And so we're going to say that to be less than 1, but it also has to be greater than -1. And so I'm going to put that in IXL. -1. You probably can't see this. Okay, so I'll switch it for this next one so you can see what I entered, but we got it right.
Okay.
Yay. So the first one, this is the answer. -1 is, or P is greater than -1, which is also less than 1. And on the number line, it would look like this. This first part is P is less than 1. And so less than 1 would be right here. And then the second part is P is greater than -1. And so the inclusive part would be right here. And so that's what we have to add. We have to add this -1 part so that we get the left side of the number line. I don't know if that, does that make sense when I say that?
I don't know, is it supposed to?
Ideally.
Okay, sure,
Do you know what absolute value is?
yes.
Do you remember?
Mhm.
Okay, so it's all the positive values because absolute value is distance, and distance always is positive, no
From
matter
0
what. Because it doesn't,
to
like, it doesn't make sense to say like I ran -3 miles,
Mhm.
and
Right.
so no matter what, distance is always positive. And so even if you have -3, meaning like you ran south 3 miles, it's still just 3.
Mm.
And so when we put this on the number line, if the absolute value is 1, then we automatically get all these positive values here that you went, like, so this is saying you ran less than 1 mile, but
Okay.
that means that you could have ran north, anything that's less than 1 mile, but you could have also ran south, anything that's less than 1 mile. And so that's why we have to use this. We have to include this negative because the negative is telling us a little bit more about direction and absolute value. And so we add this piece. It's okay if that doesn't completely make sense, but hopefully we're going to get closer.
Okay.
Okay. So here is another problem where we have the absolute value of S plus 4 is less than 3. Okay. So this is the same setup as the one we just had, which is that we have 2 options. It's either a less than or a greater than problem. And so when I look here, it's a less than problem because I have that symbol that I would make with my left hand instead of the one I would make with my right hand. And so then I have to set it up the same way, where I'm going to say, okay, well, I have S plus 4. The absolute value of S plus 4 is less than 3. But since it's the absolute value, that means you could have also gone the negative direction and still be 3. And so we add, this is the part that we add, where we take whatever this number is and we do the negative version, and it's still less than. That way we get on our number line, that way we get everything that is from 0 0 to 3 that's positive, that's what this first version tells us. But if we only use that first version, then we would miss all of these answers here. And so we have to add this piece, this second piece that has, oh, well, don't forget it could be, as long as it's more than 3, it would also work. So to solve this, after we've added this part, this negative 3 is less than, we're going to go negative 3, sorry, is less than s plus 4, which is less than 3. And then now we want to isolate the s that's in the middle. And so to get s by itself, I'm just going to subtract 4 from here. But I have to subtract 4 from both of these. And so I'm going to get negative 3 minus 4 is negative 7, which is less than s, which is less than 1. And so our final answer, and this is where I don't want to confuse you by having this number line because it really only helps at the very beginning. So our final answer is that we can pick any number that is between negative 7 and negative 1. And if we put any of those numbers in here for s, we're going to get something that works. Do you want an example?
An example of what?
So pick a number that is more than negative 7, but less than negative 1.
Well, we already have 5. Let's do 4.
Okay. So negative 4. Yeah. So that's in our range, right? So let's try s equals negative 4. And so we're going to do, I'm going to come back to this version here. So negative 3 is less than the absolute value of negative 4 plus 4. Good choice, actually, because we're going to get less than 3. And so then we're going to do negative 3 is less than negative 4 plus 4 is 0. And we're going to get this true statement, which is that so 0 is greater than negative 3. That's true. It is greater than negative 3.
Yes.
And 0 is less than 3. And so any number that we pick up here, this is our answer. We just solved it so that any number that we pick that's between negative 7 and negative 1, when we put it back into the original equation, we're going to get a true statement down here. I know it's a lot now.
Okay.
So let me share my Excel. And I'm going to put in our answer, which was negative 7 is less than s, which is less than negative 1. And when we write it, we write the one that's like the most negative, or the one that's farthest left on the number line to the one that's farthest right on the number line.
Okay.
So we're going to put so in a minute, everybody's going to come back, but I want to help you set this one up, and then I want to give you a chance to practice it and talk me through it. So first, I'm going to write negative 2. Actually, okay, so let me go back to my iPad. Okay, first of all, is this a less than problem or a greater than problem?
That is less than.
Yeah, because you can make it with your left hand. Very good. Okay, so do you remember how to set up a less than problem?
Let's see. 2b, the absolute value of 2b. No. Do I take add to b to both sides, add 2 to both sides?
You don't have both sides yet. So you need to write it where you have both sides.
Okay.
So you would take, so this part, absolute value of negative 2 is less than or equal to 6. That gives you the right side. And then you have to add this part here. And do you remember what number should go right?
There isn't anything above.
Right. And so on here, when we have a less than problem, we have to add the left part, which is negative 6. So we have to write this part in.
We have to add the left part.
Yeah, does that, are you asking or are you repeating?
Well, negative 6 isn't on the left, it's on the right.
Right, exactly.
You said we have to add the left part?
So this is what I'm considering the left part of this absolute value.
Okay.
So this problem should have this part up here, but they didn't write it. I don't know a good reason to know why we don't. But that's where we were talking about on the number line, where what they gave you was only the positive values of 6. But we also have to include the negative values. And so that's why we add this piece here. And then you do what you were talking about, where you want to isolate B, which here's our B. So do you know how to get B by itself?
I couldn't understand you. The headset was going in and out. Do I know how to get something
Sure.
by itself?
B, do you know how to get B by itself?
Subtract the 2, add the 2.
You're close. This is multiplication.
Okay.
And so you have to divide by negative 2, but you were on the right track. The negative 2 was the one that was in the way.
Okay.
So I'm going to divide by negative 2, divide by negative 2, divide by negative 2. And because it's a negative, we have to flip the sign. So right now the sign is facing this way, and we have to flip it to face the other way. And that's just like a rule you have to remember. So on this part, negative 6 divided by negative 2 is 3, which is greater than or equal to B, which is greater than or equal to negative 3. That's the answer, but we're going to write it in a different way because we want to write the smallest number first.
Mm-hmm.
And so when I write the smallest number first, I'm going to say negative 3. Small end is facing my negative 3. So I have to keep my small end facing the negative 3. And then I have my B. My small end is facing my B. And so then I have 3. This is a little bit confusing where this part here and this part here, those are the same.
Okay.
Because this one says B is less than or equal to 3. And we have that part right here too. B is less than or equal to 3. And then we have B is greater than or equal to negative 3. And we have B is greater than or equal to negative 3.
Is that it?
Mm-hmm.
Oh, okay.
I mean,
Okay.
that's pretty confused. I mean, that's a lot on its own, right?
Okay. Mm-hmm. Mm.
Okay. So I think most people are going to come back in about a minute.
Okay.
And while
Yeah,
they're
Miss-
coming back, yeah.
I was gonna. I had a problem submitting the assignment. If we have to, after you do the 5, there's a whole list that you submit it automatically. So I see that we have to do visually to the 5 problem. So can I stay after to do the because I'm having
Yeah, what do you mean there's a video link?
the Excel, the thing the gave us.
Yeah.
So I thought if we have to capture it, that we have to do it just all together, 5 problems all together.
Yeah.
But we have to do. But I thought we have to do it visually to send it to you video for each
You don't
page.
have to have a video if you don't want, but yeah, you can keep it, and I'll remind everyone of what we're talking about.
So I have one more question. Is can we just send a link to it? Can we just do a link? Or is it
You
have
do
to
a
be
link, it will probably reset back to 0.
Oh.
So let me, for everyone that is going to be here in just a minute, I think. I don't know who's all here. Hi, everyone. Okay, so Lori and I just did this problem, and I'm going to go back here. So we did this problem, and we got -3 is less than or equal to b, which is less than or equal to 3, and then hopefully it's going to tell us if that's right. There we go. Okay, so do you see how I have this 4 here? That means we've done 4 problems together. And
Yeah.
so
It's just the
So just-
submitting. I did all 5. I have to
did.
reset it again. I have to reset it again.
But if you don't, I mean,
I couldn't-
I'll take a picture of the people who are here as well, so I remember. But if you just do a screenshot that includes this questions answered that has 4, then just submit a picture of your screenshot.
Okay. To read. Is it okay if I all over again because my thing?
Of course, that's always okay.
So what I'm doing, like I'm writing down in the box. Is that okay? I did answer in
Yeah.
paper first,
That's fine.
then
That's
I'm
fine.
writing like one by one, like 5 questions.
Yep.
Okay.
Not a problem. So we have one here that we're going to do together so that you know how to do both types of problems. So as we were starting, is this a less than problem or is this a greater than problem? The one that's on the IXL right now. Can I make that symbol with my left hand or not?
It's a greater than, right?
It's the greater than. Very good. Yeah, it's not the less than. It's the greater than. You can't make. I can't unless I turn my hand that way. I can't make my right hand, or I can't make my left hand do that symbol. So this is a greater than problem. And so when we have a greater than problem, that's where instead of having the middle section on your number line, you have the outside section. I'm going to share. I put it here, hopefully. Okay. So if it's a greater than problem, then I'm going to have, I need to include not only the greater than 3 part, which is already in my problem, but also my less than negative. And so we have some notes, but the way that you're going to write this is that if I say this is A instead, then right here I have my A is greater than 3 part. But I also need to have my A is less than -3. So we have this part that will come with the problem, but we need to add this part that's not in the problem. Otherwise, we'll miss all the negative values that will also make this true. And so this is a compound inequality, but it's an or problem instead of an and problem. And so we solve these two separately. So we would say, okay, y, absolute value of y minus 5 is less than -3, and also absolute value of y minus 5 is greater than +3, and then you can just remove the absolute value signs, and then we're going to isolate y, so add 5 on both sides, and we don't have to worry about any negative coefficients, so we have y is less than 2, and then over here we're going to get y is greater than 8. And so our solution, we could write it as this version, which is y is a solution such that y less than 2 or y is greater than 8. You write it that way. or we could do it with the words, or write it kind of with the number line, which would be the number line version, which I think is easier because you're kind of visualizing it, is my number line is going to go from negative infinity until 2, and it's less than or equal to. Bracket.
So,
So
I have
all
a
these should
question.
have a line under them. Yeah.
So much is like, so the order of things matter, right? The orders matter because
Yeah.
sometimes if you get it back, like you have the right answer, but you put it back.
IXL will yell at you.
Yeah. So
It does. IXL is
the or
very persnickety. The order
Okay,
does
so-
matter. To IXL, I don't know if it matters to me necessarily. So then it has to be greater than 8 to positive infinity. So yeah, to kind of give you your answer, they want you to write it as the number that is the farthest left on the number line first to the right, because you read a number line from the left to the right.
Mhm.
And so I use the number line at the beginning to set up my problem. But then once I have my solution, my answer is no longer 3. So that I use to get it going. And so now when I look at my number line, my solution set, which is right here, is that it goes from 2 to negative infinity. That's one possible answer. And then also from 8 to positive infinity. And so all of our answers that are greater than are going to look like that on the number line. And you will definitely have a test question that asks you to make that connection. If it's a less than problem, you're talking about the middle part of the number line. And if it's because those would be less than your values. And if it's a greater than problem, it's going to go out of the number line.
Okay.
So to recap, we kind of have it. Actually, let me send this picture over because it's a better picture. Is it storming where you are?
Who, me?
Anybody?
It's kind of dark outside. I think the rain is coming in slowly.
No, not yet. Not for me.
Not yet.
Uh-uh.
It's storming here.
Oh boy.
Please, goodness, let me keep my internet. Why did you find it? There you go. Okay. So from your textbook, you have these rules, but they're written in a way that I don't love. I think they're kind of confusing, but we'll use them anyway. Where's your? There it is.
I mean, we did the questions and like we didn't know how to do the screenshot, like because
Okay.
yes,
That's
ma'am.
okay.
So
Yeah, that's
but
the
Don't
work
worry about
together.
it.
We all work together, madam.
Oh, I'm so proud of you. I don't know if you remember, but on your first day of class, you kind of like, we're working together. I was like, yeah, I bet you like it eventually. Okay. Oh, that's the same one, of course. Okay. So we've had 3 versions of absolute value. We have an absolute value equation, an absolute value inequality, and an absolute, and 2 absolute value inequalities. I don't think I sent over the right one. There. I would definitely have some version of this note open or available to you when you do your exam. You can work your way through if you're looking at a number line. That will normally help, but they're tricky to do without notes. Yeah, Ellen, was that you?
Oh, sorry. I didn't know my.
No, that's okay.
I was on mute.
I thought you said, Okay. So here are your three situations. Make them a little bit smaller, so that hopefully we can add to those. And then we'll take a break. So if you have an equation, and we'll use, let's say our equation is x plus 2. Absolute value of x plus 2 equals, and then a. And when I say a, it's going to be any number, say 3 or whatever. If you have an equation, you need to do the equation twice. You do the equation as x plus 2 equals whatever they gave you for a. It's easier if I replace a with a number. More sense? Let's do that. Let's say 3. So you would do your x plus 2 equals 3 as one equation, and then you would do x plus 2 equals negative 3 as your second equation. That's what they're saying here. Whatever is inside the absolute value equal to whatever they gave you, and, or I guess I should say, or whatever is an absolute value with the negative version. So for this one on a number line, you're just doing opposites because you just have two solutions. Then you have the situation where you have less than. And when it's less than, that's where you're talking about the middle part. And so you have to add on to your inequality. You have to add the left, this part, this left side. And so let's say that we had x plus 2 is less than 3. And remember, I can make less than with my left hand. So to solve that problem, I'm going to end up with a compound inequality where I have my x plus 2 is less than 3. That would give me the part from 0 to the positive value. But I have to add the negative value part. So I'm going to add this, which is greater than negative 3. If you don't add that second part, you're not going to get the answer right. The last version is when it's greater than. And so I can see this part here. It's greater than. I use my right hand. If it's greater than, instead of being the middle part of the number line, you're going to have one line that goes this way and one line that goes that way because it has to be greater than. And so when you write that one, you're going to set it up again kind of like equations with two different versions, which is the one they gave you. So let's say one more time that we have this x plus 2, but this time now it's greater than 3. So you would do the version that they gave you, which is x plus 2 is greater than 3. But then you also have to do x plus 2. And then it's going to be the negative version, but it has to be less than the negative version, which is what they say right here. And then, as we were talking about before, if you're doing this on MyMathLab or on iExcel, they're going to be really picky about writing your answer in order from the smallest number and then the larger number. And so keep in mind that if your answer is in the wrong order, you have to turn it around, and you have to be really careful when you turn it around because it's not the same sign. I think that this is one of the most challenging things we do in this class. So if you're feeling scared, then that's okay. Everybody good?
fine.
That was really helpful seeing all three of them together.
It was? Okay, good. And actually, I should add this part where on a number line, I should have used 3 instead of 1 in this one picture, but this one would be where you have 3 and -3, but they're just dots. So if it's an equation, then you set up your equation with the positive dot and then negative dot. If it's a less than, then you have your positive version, and then you have to add the negative version, and it's the inside part of the number line, which is going to be a compound inequality. And if it's a greater than you have your 2 parts of the number line, but they have to go outside of the number line, and so it's going to be back to 2 versions. Okay, so let's come back at 10:45.
It said I was the host, so we enjoyed
Did
it.
it? Well, there you go. See?
We ask a lot of questions from Lori.
Uh-oh.
Professor Bugs says
Yeah.
that you all get A's, and that is fine by me. Oh my goodness. The worst part is that because the internet fails, I don't have to tell you that I is coming back, hopefully.
Okay.
Okay. All right. So we were in the middle of manipulating this equation. And I'm going to divide by -1, but I'm going to divide everything by -1. And I get y equals a negative divided by negative is positive. So y equals x minus 1. So that's kind of a nice review for changing a standard form into slope and form. And then when we were talking about chapter 8, we were talking about how you could graph from this version, which is y equals x minus 1. So -1 is our y-intercept. And so we have this point right here, and -1, because that's our y-intercept. And our slope is 1/1, positive. And if you're not sure, you can just kind of put this right in there. There's an understood 1. And so our rise is up 1, and our run is over. So we have our -1, which is our y-intercept. And then we're going to go up 1, over 1, and we hit our line. So there's our equation. Our inequalities work the exact same way, but the difference is that on an equation, only these points on the line would work in the equation. So I pick this point, right? That point is on the black line. So I'm going to put a black point right there. And that is point -3, -4. And that's on the black line. So I'm going to substitute that into our equation. So here's my equation. My y is -4. -4 equals my x, which is -3 minus 1. That's this equation that we manipulated. And you're going to get -4 equals -4. Because remember that -3 minus 1, the signs of it, so that you add them.
So you can choose any points?
Yeah.
Okay.
That's a true statement, right? -4 equals -4. Yeah, that's true. So on an equation, which is what this part is, if it's an equation, then all the points on the line are the answers. But now that we're going to talk about inequalities, we're going to get this line, which is a boundary, and it's going to be the same as when we do a number line. It's either include those numbers, or it's just going to start at those numbers but not include them. Like if we have y is greater than 3, it's everything that's more than 3, but we can't include 3. So when we're doing our graphing, we're going to start the same way we would start before. We're going to graph our line. But then, because it's an inequality, we are going to have to shade either the blue region or the red region, because on graphing inequalities, it's going to be not only the line, but everything else that is either greater than or less than that line. So that's what we're leading to. So to get there, we're going to do manipulating. Oh, something just happened there. I just panicked. Okay, so to get there, we're going to start with manipulating inequalities so that you can graph them. And then I think the best way to figure out if you're supposed to shade the blue part or if you're supposed to shade the red part is to pick a point. We just did that, but we're going to do it a little bit different. Okay? Okay. So let me give us our inequality line. We'll start off a little bit easy. And we're going to do x plus y is less than 7. So you could graph this on your own on Desmos, but what do we normally use as the strategy to graph? Do we keep it in this form?
You turn it to an equation.
Yes, we can't turn it completely into an equation, but we're going to treat it like an equation. And we're going to get our y all by itself so that we end up having the version where if we have y equals 2x plus 1, then we know that we have a guest in our class today. You might see her. We know that this right here is our y-intercept, and then we know that this right here is our slope. So it's going to be the same. So I'm going to manipulate my equation to get y all by itself. So I'm going to subtract x, and I'm going to rewrite it. And when I rewrite it, the only time I'm going to change my sign is if I have a negative coefficient. That rule still applies. If I divide or multiply both sides by a negative coefficient, I have to flip the way my sign is facing. Otherwise, I keep it the same. So I've got y is less than negative x. And so it might help us to write this as negative 1 over 1x and then plus 7. If writing it with the negative 1 over 1 is confusing, I don't have to do that. Okay. So now when I graph this, I'm going to send over. I guess not. Okay. So if I had to graph this by hand, I would do the same thing as an equation. So I would go down, my y-intercept is what?
Y-intercept is 0, 7.
Yes, very good, 0, 7. Or if you just said 7, that would be right too. So let's pretend like that's 7. So I'm going to graph a point at 7, which is this number right here. Now my slope is 1 over 1.
You go down 1 and then over to the right 1.
Yep, exactly. You can go down 1 to the right 1. You could also go up 1 to the left 1, but you have to make sure that your line is negative, so it goes down like that. Okay, so in a minute, I'm going to add, there are some rules about the way this line looks. But because it's an inequality and not an equation, it's an equation, that line is my answer. But it's an inequality, which means that there's going to be a part of a graph, which is my answer. And so to figure out a part of my graph, which part I should shade, I'm going to pick a point. And unless your line goes through the one, you're going to pick 0, 0. So unless that's on your line, pick 0, 0, because 0, 0 is going to be the way to solve this. So I'm going to test the and to do that, this is my x value and this is my y value. So I'm going to put in this equation, or actually it's an inequality, do y, let me write it up higher. Okay. we have a request to use blue. So I'll use blue. Okay, so I'm gonna go y is less than -1/1 x plus 7. I'm gonna substitute 0 for y, and I'm gonna substitute 0 for x. So now I'm gonna have 0 is less than, and then I'm gonna drop this -1/1, but we could do -1 times 0 plus 7, and I get -0 less than 0 plus 7, which is 0 is less than 7. Okay, is 0 less than 7?
Oh, yes.
Yes.
Yeah, very good. That's a true statement. That means that 0, 0 is one of my answers. And so that means that I need to cover the 0, 0 part of my graph. If when I put in 0, 0, I got a false statement, like 10 is less than 7, then I would shade the other part of the graph. I would shade this part because 0, 0 is not an answer. And so our graph, if we put it on Desmos, but I'm going to just use your textbook. Okay. I don't know if you all remember, but I said that I was somewhere else because of the internet. So that's why we have friends joining us today.
Okay.
So this is our graph right here. We start out with our line, which you can see has our y-intercept of 7. And then we have our up 1 over 1. We have our slope. And then we pick 0, 0, unless the point goes through it. But we pick a point, you can pick any point. And if it's a true statement, then that's shade over. And if it's a false statement, then you shade the opposite side.
So, ma'am, one question. So, like, how is going to be the question? Like, the point is going to be mentioned to us in the question. So that's how
No, so
we
you
share
pick a
the
point.
We will pick a point. Okay.
However, I would always use the point 0, 0. The only situation where you don't use the point 0, 0 is if the line goes through 0, 0. If the line goes through 0, 0, you have to pick something else. Otherwise, you won't know which side to shade because the line is already on it.
So, like,
So
if
as
we
long as
choose
the
like
line doesn't go through you,
one or -1
Yep.
or -2 or 2,
Yep.
like, okay.
you can pick any point you want. Point of picking the point. When you pick a point, you're just deciding, does this point work? If it works, then you shade that part. And then you say, well, if this point doesn't work,
How
then
do
you
you
shade
know?
the other part.
Sorry.
How do you know?
How
Nope.
do you know that
Because when you put in,
the
like when
equation-
you have this point, when you put
Mhm.
the first number for X
Mhm.
and the second number for Y,
Mhm.
if you get a true statement, it works. And so you have to over that point. If you
Okay.
get a false statement, it doesn't work. And you have to shade the part that doesn't include that point.
Okay.
So one thing that I want to add on is you'll notice that this line is dotted. It's a dotted line. And so that's one rule that we have to add. I'm going to go back to my iPad. It's very similar to the curve bracket, square bracket rule, or open circle, closed circle rule. And that is, if you have less than or greater than, then it is a dashed line. And that means that the answers start at that line and then go either up or down, but they don't include the line. If you have less than and equal to or greater than or equal to, then you have a solid line. And that means that you get to have all the answers that are on the line and whatever is above it or below it. So we're going to practice this, but I'm going to give you some notes. So for number one, the first thing that you want to do is you want to rewrite to be in intercept form. That's a slope. She's okay. It's okay. So the first thing you want to do is rewrite it so it's in slope-intercept form. It might already be in slope-intercept form, and if that's the case, you don't have to rewrite. And then you want to graph, and you're going to graph exactly as if it were y equals mx plus b. The only difference is that it's not going to be equals. It's going to be greater than or less than. Then you're going to pick a test point. And remember that normally you want to pick 0, 0, but you could like I think it was it Hani? Did you say you could pick anything?
May I say?
You sound the same on Zoom. Your voices sound the same. But yeah, you can pick 1, 1. You can pick really annoying. You probably use 1/2 and 3/4, but like why would you? So you're gonna pick 0, 0 unless the line goes through 0, 0.
Which
And
point,
then,
ma'am, which point is the popular point? Which point?
0, 0.
Oh, 0, 0, the
0, 0 is the
popular
point I would pick. The only time I don't pick 0, 0 is if my line goes through 0, 0, and then I pick the next easiest number to find. So normally it's super helpful if at least one of these is 0. So I'll show you, I think, in a minute. So then after you do your test point, if the test point gives you a true statement, then you cover it. There we go. Can I make this big? Yeah. So if the test point works, you cover it. It's like, love it. If the test point is false, then cover the opposite. And we're going to spend the next at least hour practicing this, and it will feel much more natural because as long as okay at graphing, then this doesn't add too much. But it sounds like a okay. So we're going to do this one first. So we have 2x minus y is greater than or equal to 3. And so Adnan and Kaku and somebody else, was that
yeah.
actor on, yeah. We stayed after on Tuesday.
Oh yeah.
And remember how when we were doing those problems, we said like at the beginning, sometimes it's helpful to do the curvy brackets or the square brackets, you remember?
Yes, ma'am.
Mm-hmm.
Yeah. So when I look at this problem, no matter what, this one is going to be a straight line because it has less than or it's greater than or equal to. On the problem that we just did, this one I know right away is going to be a dash line because it's just less than, it's not less than or equal to. So I might do that in my notes right away to be like, oh, no matter what happens, this problem is going to be a straight line. Okay, so I'm going to do this on my own quietly, but the first thing I want you to do is to change this equation or inequality to be in slope intercept form, which means isolate y. Practicing that, I'm going to do it too. but I'm not going to say anything. Okay, so what I have on the slide is what this would look like when you've changed it to slope intercept form. So if you can get there, you're off to a good start. Okay, anybody have a problem getting to this part on their own first?
I have a question.
Yeah,
I think I understand my question, but I want to ask it just for the sake of
I love
understanding.
that you ask questions. I will never be mad at you.
Okay, so I think I did mine right, but I think the negative, I forgot that the negative, the sign switches. So that's the tricky part
Yes.
about it because
Yes.
first of all,
Yeah.
when you have the y negative divided by the -1, you'll think that's a
Mhm.
positive. So that positive, you'll think that the sign doesn't change because that divides to be a positive. So you
Mhm.
still have to switch the sign. Right?
Yeah, you do.
Okay, because divided by a negative.
However, on these problems, normally the answer is a graph, and so it won't actually mess you up that much.
Okay.
Because if you don't flip the sign, it's okay. Because people learn to shade based on the sign, but that's a really arbitrary rule. And so that's why most books teach the test point instead. And have this sign pointing a different way, it's not going to impact you that much.
Okay. But so it won't have a change in the graph. That's what you're saying, right?
Right. You're going to get the same line.
Okay.
And as long as you do a test point, you're going to shade the right part. And so it's not the biggest mistake in the world.
So ma'am, for this, now we will get the test point 0, 0.
Yeah. So first let's graph it because we need that line first. So my y-intercept is what?
-3.
Yeah. I'm going to put a point right here at -3.
You go
and
up,
then my slope, yep.
You go up 2 times and then right 1.
Yep, right here. And then I'm going to use this iPad has this like ruler feature. Maybe it's here. There it is. So it helps me. Okay, so now this is a solid line because it's greater than or equal. So if it were just greater than, I would do a dashed line.
I have one more question. So
go ahead.
Like what we did before with the rise and run, it comes to this inequality graphing again. So it's
Yes,
just
exactly.
in concept that you just have to graph it with shading the region, right?
That's exactly it. Okay. Yeah, this is almost the exact same. The only difference is that because it's an inequality instead of an equation, the entire part of the graph instead of just the line. And so we have to figure out, are we supposed to shade this part of the graph or are we supposed to shade this part of the graph?
Okay.
And to answer that question, go ahead, honey.
I'm sorry. I have a question about how the second point for -1 and 1, how we found this one.
Yes. So we looked at our slope, which is 2.
Yes.
And that's the same as saying 2/1.
Oh, okay.
And so what we did is we started with intercept, and then we just went up 2 over 1.
Okay.
Rise and
Because
run.
slope is always rise and run. Very good. Yep. And it's positive, so it's going to lean this way. If it was negative, we talked about this 2 weeks ago, you can either go up 2 and to the left 1, or you can go down 2 and 1, but either way, your line has to go the opposite way. Okay, so now, in order to figure out what part we have to color, we're going to take a
Ma'am, the
test
down
point.
part. I already
Think so?
figured it out.
You
Ma'am,
are such a
yes,
show-off.
yes, ma'am, because this 0 is less than or equal to minus 3,
Very
so
good.
that's not a correct statement. So
Very
we
good.
have
I'm
to.
so proud of you.
Yeah, thank you so
Yeah.
much. I hope I will
Yeah.
do better than the quiz, ma'am.
I bet you will. Okay, so we're going to pick a test point, and like I said, we're going to pick 0, 0. The only time we don't use 0, 0, we have any line that goes through 0, 0. If it goes through 0, 0, then it's not a good point to pick, and you have to pick some other point. But as long as 0, 0 is not in the line, then you want to use that. And it's called a test point because we're just testing to see if it works or not. And so now I'm going to go, and you can plug it in up here, or you can plug it in here. Some people are like sticklers for always going back to your original equation, because if you made like a little mistake, then you might not get the right answer. I don't really care, but I'm going to go into the original. So I'm going to go up here, and I'm going to do 2 times 0, because my x value is 0, minus 0, because my y value is 0, is greater than or equal to 3. And we're going to get 2 times 0 is 0, minus 0, greater than or equal to 3. This is my test, by the way.
Ma'am, I have one question. And ma'am,
Yep.
if the slope is gonna be like in minus, so then we have to change the signs, or?
So if the slope is, instead of going, yeah, hold on. Actually, can I come back to that one in just a second, Adnan?
Yes, ma'am. Okay.
Remind me, okay? Okay, so I just put in 0, 0. And I plugged it into this equation. Again, you could plug it into this equation. That's what Hani did. And he got 0 is less than or equal to negative 3.
Ma'am, Adnan
Okay.
got this.
Gosh almighty, you too. I'm so sorry. I'm glad you're laughing and not thinking that it's some horrible microaggression that your snotty white teacher is doing. Okay, so 0, 0 does not work, right? Because 0 is not greater than or equal to 3. That's false. That is sad face. So that means that we are going to cover 0, 0. If 0, 0 works, then we will cover it. 0, 0 doesn't work, then that means that we cover this part. If you wanted to test again, you could. I wouldn't, but you could.
I have a
Pick
question.
any point, hold on. Pick any point that's in this part, and all of these points will work in this equation or inequality where you get that's true. All the answers that are over here, those are not solutions. And so we're showing all of the possible values of XY combinations that will work in this inequality. Okay, Cuckoo, what's your question? Cuckoo? Cuckoo!
I think Cuckoo is away from the session.
He went away. Okay, so then I'm going to answer the question about the negative slope. And I'm going to stop guessing if it's Hani or Adnan, because clearly I can't figure it out. Okay.
Okay. Sorry, I'm back. I had
Yes.
somebody at the door.
Hi, Cuckoo.
My question was like, the 0, 0 and that graph we
Yeah.
just did. I think you
Mhm.
erased it, but I was just wondering, like, can you pick any point rather than 0
Mhm.
for that graph?
Yep.
Okay.
Lori, again, you are hosting the party.
Yep, I believe I am the host now.
I just saw that.
Did she leave again?
No, maybe she will come back to
Okay.
fix the problem.
Who is the teacher now?
It was me again.
All right, well,
Yeah.
everybody's still good. It's a good thing that you can't hear me every time that the internet closes out. It's not language for children. Oh my goodness. Okay. I tried closing some things, Alan, so hopefully it will be okay. Okay, so here's our Desmos. Here's what we just graphed. And so like Cuckoo was just asking, you can pick any point you want to figure out what to shade. 0, 0 will work the best because it's super easy, but you can pick 1, 1. You could pick, I would use something that's on one of the axes if you can. Like I would like maybe 10, 0. Anytime there's a 0, that tends to make substituting a lot easier. But the whole point of picking a test point is just to figure out which side of this will be shaded.
One more question. So the
Yeah.
point has to be a positive. It can't be to the left of it, like the negative. You know, because we're shading everything that's going through like the positive
Yeah.
side. So we
Because
can't,
when we put, yeah, it just gets a little tricky because like down here, this point is negative, negative, right? In this one little area, like negative or 2, negative 11 is a solution. Why don't you let me trace that? Oh well, 2, negative 11 is or negative 2, negative 11 is a solution, and that's why like if you say just the positive or negative, it gets a little confusing. I know people who learned it as like shading up and shading down, and so since our answer ended up being y was less than we shaded down, but that can become confusing too. So we pick a test point and we pick a point to see if it works. If it works, we shade that whole side of the graph. If it doesn't work, we shade the whole other side of the graph. And the line is the thing that divides it for us.
Okay.
Okay, so to go back to the question about negative slope, I'm going to rewrite this in the way that we solved it, which was y is less than or equal to 2x minus 3. So this is the exact same thing we just had. Okay, but if it were y is less than or equal to negative 2x minus 3, do you see how the line now goes the opposite way? When it was when this 2 was positive,
It was
we
on
go,
the right side.
yeah, we go up up and then to the right. Up to the right one. But if it's negative, right here, we go up to the left one because it's a negative slope. A negative slope leans back like a backslash, and positive slope leans forward like a forward slash.
And we will not
Those
change
are
the sign.
buttons. You only change the sign if you divide by or multiply by a negative on both sides. We're going to do a couple more. One last thing I want to remind you one more time is notice how if I change this, there we go. Okay, so do you see how when this symbol is a less than, notice how they had this dotted line?
Yes, ma'am.
And when my
Dash
symbol
line.
is, dash line. And then when it's not, it's a solid line. And so what this means, like I said, it's the exact same as the curve and the bracket. If it's a solid line, it means that all of these points will work. So if you put in 2, 1, 2, 1 will give you a true solution. But if it's a dashed line, if you put in 2, 1, it won't work. And so solid means this line and everything else. And a dashed line means everything else. Just like we have less than or less than and equal to. Let's do 2 more. I think you'll kind of have a good feeling after that. And then if anybody else is still not sure, then you can stay after. Do we feel okay with that plan?
Yes, ma'am.
Okay.
Yes.
So, oops. I did not want to do that. Here's my pause. Oh, because I want to go to here. So I'm not normally a steps person. Hopefully you know that about me. But I do think it's helpful to kind of have these steps in your mind with graphing. So we're going to change to slope-intercept form so it's easy to graph. We're going to graph it with either a solid line or a dotted line. We pick a test point. If that test point works, we shade that part of the graph. If it doesn't work, we shade the other part of the graph. And then hopefully we're all done. So we're going to do.
And ma'am, when you will post the homework, because homework
Today.
help a lot, ma'am, when we
Yeah,
doing
so
the
today,
homework.
and it will be due. I didn't want to get you off the Thursday schedule. I wanted to keep you on that schedule. So it'll be like normal. It'll go up today, and then it will be due next Thursday. But you're going to have 2, but they're going to be small. So it's going to be 2 that are each about 10 problems.
Okay.
So it will make up for the assignment that wasn't up there last week, but it doesn't. You won't have to do extra work. That's the fairest way that I could figure it out. If you hate
And the
me.
second test.
Second test becomes available on Sunday and is due a week from Sunday.
Oh, okay.
Okay, and it will cover 7, 8, and 9. 7 is one of the tricky ones. That was the expressions and equations with rational numbers. That's where you have to do a lot of stuff with LCD. 8 is like a bunch of graphing. And 9 is this, which was inequalities and absolute value. The good thing is, like Kaku said, we're reviewing a lot of chapter 8 in doing this section right now. Okay, so let's take this. We've got 5x. Little thing started to fall. 5x plus 4y is less than or equal to.
You can't see the
You
screen.
can't see?
Yeah.
Thank you, my love. Well, it was messy anyway, so let me start again. Okay. 5x plus 4y is less than or equal to 20. So kind of like we talked about as far as one of our strategies, right away, you should be able to tell, is it going to be a solid line or a dashed line?
Solid line.
Very good. It's a solid line because it's a less than or equal to. If it didn't have this part right here, it would be dashed. And there's nothing that you can do to the inequality to change it from an equal to a not equal to problem. That will never change. It might change which way it's facing, but you're never going to change from less than to less than or equal to. All right, isolate y so that this is easier to graph. Does somebody want to walk me through?
Yes, ma'am. For we will subtract 5x from
Very
both
good.
sides.
Can you subtract 5x from 20?
No, ma'am. We will write down like 4y is less than or equal to minus 5x plus 20.
Very good. They're not equal. They're not like terms. If you remember way back at the beginning of the class, they're not like terms, so we can't combine them. And then the reason why we put the x term first is because our y-intercept is always at the end, so it's super helpful to keep there. Okay, now what?
No, ma'am. We will divide by 4 the whole,
Yep, so,
both sides.
but everything. Yep, everything has to divide by. And so now
So
we
now
have
we are
y.
ready to plot the graph after this.
Exactly. So we have negative 5/4, and we're not going to freak out that we have a fraction because that just means go up 5, go over 4. The only thing is we have to know which way to go over. And then we're going to have plus 24. So the graph
5.
that I have
No,
in here.
that's plus 5.
5, right?
5.
Thank you.
She's just
I'm
testing us.
testing you. Right? Thanks, Alan. I'm testing you. Okay, so my graph doesn't go up to, oh, actually it does. Sorry. Now that I have the right answer, let me put my graph in. Okay. So my y-intercept is 5. It's this one right here. And then because I'm at the top of my graph, I'm going to go the opposite way. You can go up 5, 1, 2, 3, 4, 5, and then over 4 this way, but I'm off my graph. So I'm going to go down 5, 1, 2, 3, 4, 5, and then over 4, 1, 2, 3, 4. I'm going to end up right here. And then I'm going to use a ruler to make a nice line. And we already said that it's solid, it's not dashed. So a little test, are the points on the line part of my answer?
Yes.
Yes, very good. That might be something that shows up on your test. Yes, the points on my line are part of the answer because it's equal to. If it was just less than, the points on my line would not be part of my answer. It'd be everything past that. Okay, now what?
Now you shade down.
Yeah, but how do I know? How do I know if I got to shade this
Test
part
point. Test
or
point.
this point? Test point. Oh, my love. Yes, and so because this line doesn't go through 0, 0, I'm going to pick 0, 0. And if it works, I cover over 0, 0. If it doesn't work, I cover this side over here that's not over 0, 0. I suggest that you plug your original version, but it doesn't actually matter. But so we're going to do, let me make this a little bit smaller. Smaller. There we go. All right, so I'm going to do 5 times 0 plus 4 times 0 is less than or equal to 20. 0 plus 0 is less than or equal to 20. 0 is less than or equal to 20. So what does that mean? Does it tell me?
And that's
It's a true statement.
One at a time.
Cuckoo, go ahead.
It's a true statement.
It's a true statement. Very good. Was it Adnan? Adnan, were you the one that said something too?
I was gonna say the same thing, Lem.
Okay, very good. It's a true statement. If it's a true statement, I cover over my 0, 0. So that means that all of these points in here, these are all possible solutions. So I can pick any point I want in that blue zone, and I can plug it in just like I did a few minutes ago, and I will get a true statement.
And then
Those
we
are
would
all
be
my
able
solutions.
to make the half side shaded on the MATLAB.
I think so, yeah.
Yeah,
But you
I
would
gotta-
have to.
You know, the math
Yeah.
lab sometimes is very difficult because it doesn't, even if you put in like the right answer,
I know.
it will not let submit it. So,
This is,
I mean,
I
how are we
think
gonna?
I've lamented about this before, which is that the people who make these things are not math people, and they drive me crazy. It's like there's no reason for you to not have a button that lets us write with a fraction, and there's no reason for you to be so picky about what an answer is. If I'm writing the same thing, it is the same, but I don't have the same space.
Right.
If you get one that is giving you a hard time and you think it's the right answer, just take a screenshot and send it to me, and I'll double check it, and you'll get credit.
Okay.
Because that's just the computer being annoying. That's not you.
Right.
And to be honest, a lot of times, I like Desmos doing this graph for you. I do think it's worth your time to know how to graph these, which is why we're doing it longhand.
Mhm.
But the truth is Desmos will show you how to do it. So there's that. Okay, we're gonna do one more example. And this one example that I'm showing you is gonna give us one where we can't use 0, 0 as a test point, or it won't help us to use 0, 0 as a test point. So a lot of times, if you use this question like on a GRE or something, because it's tricky to make the graph, then what they'll have instead is like 4 graphs and you have to pick the right one. Or they might have 4 points and you have to say which one is true or which one is false. And so if that were the case, normally they'll give you like 1, can't do that, like 1, 2, 3, and then a point over here. And they'll ask you which one is a solution. You could do that by substituting each of these points into your inequality and seeing which one works. But probably it would be faster to graph, because sometimes they'll do this thing that maybe you've seen it, where they'll have A, B, C, and D, and A will be like only 1, and B will be like 1 and 2. Have you seen these? 1 and, or they'll, I guess maybe a different way, like they'd be like point A is a solution, or point A and point B are a solution, or only point C, and they like will write it in a confusing way. And so if you have a graph that's already made, it's really easy to figure out which points are solutions. And that's more of a testing strategy than a comprehension strategy. So if you got confused there, it's okay. Okay, last one. Let me make sure I have the right one here. X is greater than 2y. Dashed line or solid line?
Dash line.
Dashed line, very good. So that means that our solutions are not on the line, they're just past the line. All right, isolate y.
It's like a tricky one.
It is a tricky one, yeah. So if I want y to be all by myself,
I think when we have to add +1 or 0 on the right side.
you could do +0 if you want, that might help you. I would do this first. So I want my y to be by itself. That's easier to graph. And so right now that 2 is in the way. So I'm going to divide by 2 on both sides. And I'm going to get, and this is something that might help you, that's really a 1. And so then I'm going to get y, and then I'm not going to flip the sign. I'm just rewriting it because my y was over here on the right, and now it's over here on the left. And so the small side was facing my y, and so my small side is still facing the y. And I get 1 over 2x. And then if you want, you could do plus 0. So who was confused? Nobody. Okay. You are all liars. Okay. How come nobody's laughing at my jokes? I'm funny. Me.
You are. We're just getting tired.
Okay.
You're very funny.
Thank you. All right. So my y-intercept is 0. I had to add that. If there's no constant, my y-intercept is 0. We talked about that. That was actually, Cuckoo had a question about that way, way, way back. All right. So now, because I have this 1 over 2, it's up 1 over 2. And it's positive. So I'm going to go up 1 over 2 right here. I'm going to draw a line. We already said that it's a dashed line. So I'm going to go like this, big old dashes. Okay. I'm not going to pick 0, 0. How come?
Because already the y-intercept is 0.
It's on the line. So if this point, whether it works or doesn't work, it's not going to tell me anything because it doesn't tell me what side to shade. So if 2, 0, 0, you have to pick a different point. You can pick any point you want, but I would pick something easy. Pick like 1, 1, 0. You could pick 1, 1. 1, 1 will give you this one.
If we pick 1 minus 1, ma'am, so that would work.
1 minus 1, that would work. Yeah. All right. So let's do 1 minus 1. So that's one he just said. 1 minus 1. This is my x. This is my y. I'm going to plug it in back here to my original version. My original version had x is greater than 2y. My x is 1. 1 is greater than 2 times y, which was negative 1. So I get 1 is greater than negative 2. Is 1 greater than negative 2?
Yes, ma'am.
Yep. So do I cover that point or do I not cover that point?
Yes, ma'am, you cover it.
Yep, I cover it. There you go. If you had picked a different point, if you had picked a point over here, let's say you picked 0, 5, you would get a false statement and you would know to cover the opposite. Okay, so hopefully that cleared this up a little bit. Use 0, 0 every time you can, unless the line goes through it. Pay attention to dashed lines and dotted lines and what it means. Solid lines, I said dashed and dotted, but those are the same thing. Dashed or solid, solid lines means include those answers. Dashed line means just past those answers. And manipulate the inequality to get y by itself. And have that note, those notes about absolute value equations, absolute values that are greater than, and absolute values that are less than. That's what will get you through chapter 9. All right, my dears. Any questions?
Should we put our names in the chat for attendance?
I already took a screenshot So I think we're okay.
Okay.
I'll do one more. Yeah, that way if something goes wrong with your IXL, then I'll still give you the points. I know my friends who are always here. Oh, Rita, though, you're here. Hi, hon. Okay. So homework will be up today, and so will the videos. And then you'll have until next Thursday to do your homework, and then look for your test on Sunday. And exam 1 will be graded
Right.
by Saturday evening.
This coming Sunday, we should do the test. Sunday.
Yeah,
coming
so
up?
you have a week.
Okay. I have a question for me. I don't know about. I have.
Yeah.
If I can ask.
Yeah, give me 1 second. The reason why
Oh,
you have another exam is because I want you to be able to get feedback and get half those points back. It'll help your grade. And then, like we said, the final exam is short. So anybody who wants to leave, you can leave. Anybody who wants to stick around and listen to questions or talk to me, then you're welcome to stay.
And the assignment which we did today, you said that you guys need to take the screenshot and then you need to upload that. And
Yeah.
I'm like, we did, but we didn't know how to upload it. So
I'm gonna trust my regular
we
friends
did
who
that,
are always
ma'am.
here. I know you did. I
Yeah,
know my
that's-
sweet one.
that's
So
fine.
we all.
All of
be
you will get
graded?
credit. Yeah,
Oh, thank you so
you'll all
much.
get
ma'am.
credit. No
Thank you.
problem. It'll be
Yeah,
for
that-
the people who aren't here. I'll give them some better instructions about how to do it.
Yeah. That was my
All right,
question.
no worries. That was your
Yeah.
question too?
Yeah, because I only uploaded 3. The other 2 would
Oh,
not
that's
upload.
fine.
I'm like, what's going on? Like, I only got
That's
3
okay.
when you see the submit. So that's what
okay.
My thinking and Cuckoo thinking is the same. So what Cuckoo is thinking, that's what I'm thinking.
Oh, my sweet.
It's okay.
Okay, yeah, no worries about your participation grade. What I care about more is that you know how to do those inequalities with absolute value because they're tricky.
Okay. With these, so when we have like a test, we'll know which, like, it'll say graph the certain inequality, right? Because I know we have the absolute value, and then we just did this one that we just did before, so we'll have that how to solve this thing.
Yep. And then I just have to work on D2L. I set up that assignment that you did last Thursday that was kind of long, where you were doing transformations, where you were making the graph shift up and down. Those answers were loaded, but I guess I didn't check one of the boxes. So, which we talked about this yesterday or Tuesday after class. I'll make sure that that is up so that you can compare, because the major hint, doing transformations, making graphs moves up and down, that is not only going to be on this test, but it's definitely going to be one of the 4 questions that will be on your final. Making graphs do what's called transformations, moving and shifting.
And the shifting, stretching, you're talking
Yep,
about?
shifting, stretching. That's a
Okay.
concept that shows up a ton in pre-calculus, in algebra 2. It's something that's going to keep coming up. That's going to be one of the things that you're going to have.
So with the test, right? So it's gonna be like steps that we have to do, right? Like to give an example and stuff. You said only 4 for the final.
On the final, yeah. On the
Only
final,
4
there are only
questions.
4.
Okay. And then that means but it's gonna be different. Like honestly, it's gonna be
Yeah, it's
difficult.
gonna be a lot different.
Okay.
Nah, so it'll be like perhaps, I'm not saying yes, but maybe there might be a
one question
problem.
will take 1 hour.
No.
It's not that much
No.
hard.
No, but so one question might be that you fill in. Like I won't tell you, move it to the right. I'll just say you want to move, and then you'll pick right or left,
Okay.
and then you'll pick how many units, and then you'll pick some of the other ones, and then I'll ask, and then you'll say so this is what the equation should look like, or this is what the graph should look like, so that you all have the different answers, and you're just making connections between. If I say I want to go to the right 5, how do I do that?
Okay.
If I say I want to go to the left 2, how do I do that?
And we can do it, we can graph that on the paper and we can scan it and then send it to you as an
Yep.
email so you will know how we did that.
Mhm. Yep.
Okay.
I have one more question. So are we on
course you do.
schedule for the class? I know that we kind of like
We are.
we're on
I
schedule.
can't
Okay.
believe it.
Okay. I'm
I was
because-
really worried.
okay.
Yep, we
Wow.
only have 10 and 11 left.
Okay.
And we have 2 weeks. So we'll be able to do 10 and 11. There is a little bit left from chapter 8 where we were graphing with a parabola, but that's one of the concepts in either chapter 10 or 11. And so it'll like fit in there really easily. So you don't have to worry.
Okay.
But we will have class on that Thursday, and then you'll have 48 hours to do your final exam. So you won't have, like, in a lot of classes, it's traditional that your last day of classes is just your final. We won't do that. But the stuff that's covered the last day will probably not be on the final. There might be a little component of it, but not a lot.
Okay, sounds good. Thank
Oh,
you.
good. Sure.
All right.
All right, friends. You're doing great. Anybody who wants to stay and talk to me, let me know. I'm going to stop recording now.
All right, ma'am. Have a good one.
Okay,
You
thank
too.
you.
See you on Tuesday.
Bye, my friends.
Okay, bye-bye.
Bye.
Hold on, Rita. How do I?